Again, welcome to our office. My name is Igal. I've been at Medidata for a little bit more than a year now. I'm a senior applications engineer, and I'll cut it short and dive right into the topic. But before that, and my colleagues will approve of this too, that I've always liked to start with a small quote or something that represents that context a little bit. So I found this recently, and it says, if I've learned anything from podcasting, it's don't be afraid to do something you're not qualified to do. So you'll be the judge of that today, but this is my first meetup talk, so be gentle. All right, so today I'll take you through a journey on how we are using type classes along with Akka HTTP. So I'll start a little simple and start with explaining type classes. How many people know, haven't heard, no idea, or like, how many people know about it, heard about it? Yeah, all right, wow, tough crowd. Okay, so to have a more abstract definition to it, we can say that a type T is a member of T type class C if there is an implementation for T of the behavior that are defined in C. So what this basically tells us is that for any given type T, if we want to include the behavior that is defined within the type class C, type classes basically allow us to do this without not having need to change the actual code itself, the actual class's implementation. And in some cases we might not want to, but in some cases we might not actually even have access to that class, but we still might want to add some additional functionalities to it. And specifically in our case, this allows us to combine a good amount of generic code into common patterns and extract them in a nice way. And to give a very, very basic example for this, the ordering trait in Scala language itself is an example of how type classes can be used. And I'll go with two simple examples, and I might skip the second one depending on my timing, but I'll start with ordering. So let's say we have a sequence of integers, and when we call the method sorted, we get a sorted sequence, and this is all nice because behind the scene there's an ordering defined upon integers that allows us to sort these numbers. And in our case, let's say, and this, before my own example, this is the definition of the sorted method. So here we can see that for type, let's say, B here, for type A, which is a subtype of B, the other way around, and we say that there is an implicit ordering defined, so that allows us to call the sorted method and then compare to, well, in our previous example it was integer, but in our next example, let's assume that we have this class, which is a record, which is an album name, and the artist name. So I create a sequence, and if I try to sort it, then I'll get this error from my Scala compiler. And it says no ordering is defined for my class record. And in our case, well, so now what we can do is basically, and this does not necessarily need to sit in the record object, but for convenience, we'll continue with that. I can say that I want my records to be ordered in a certain way, and this can be changed. And what basically defines is that my ordering takes in a type parameter, which is a record, so that I define this behavior upon the record class. And this says that this ordering type class requires me to define the compare method. So I get two records, and I say, first compare it to the according to the artist name, and not compare it to the album name. And the beauty of this is that, one, I don't need to change anything in the record. And then the second is that if I wanted to do different kinds of orderings, I can define multiples of them, and then I can use them accordingly. But just a side note here, implicits can be troubled, and I've listened fair share of talks about the evils of implicits, but they have their use when used properly. But if you have multiple implicits defined, which is basically saying the compiler that this ordering is defined in my global scope, but if you have multiple, the compiler will be confused, so you either need to be careful about which one you want to import, or if you want to be more explicit about it, you can actually call the sorted method with an explicit parameter saying that use specifically this one. This is another example, but I'll briefly go over it. But this is basically an example from Play Framework and how type classes are used to define marshallers and non-marshallers for custom objects that you might have in your library that will allow you to convert them into JSON objects. I'll be continuing about an HTTP example, so I'll spare it for now. So in our case, I don't know how many people are familiar with Akka HTTP, but that's not the topic here, but I'll just give a brief overview where this is basically defines a route in our API, and it defines what method HTTP method will be receiving, what will be the received entity, and it allows us to have a marshaller on marshaller here, and then we get our request. We have our service here, and it does something. We have our success cases, failure cases, and we handle everything. We have a response here, and the response is returned. So this looks nice in case of a single endpoint. However, currently in our repository, we have 31 endpoints. Some of them support multiple actions, and some of them support multiple versions. So the math ends up this piece of code being replicated on way too many times to not to do anything about it. So here I'll switch to the editor, and let's see. So here I have my original. Does anybody mind if I sit? No? Okay. All right. So here basically is my current implementation of my route, and for the sake of simplicity, I'll just explain that the JSON support, we use Circe for serialization, so these are coming from Circe, and some basic route objects that are coming from Akka itself, and this is our own error handler, so that, you know, I'll spare you the random bits. So here what we have decided to do is take these functionalities and try to convert these into type classes so that we can end up with a more generic definition of what our route can be. So here, this is the extraction of all the common items that we found in every single thing. So our generic route takes in 4 different types. So the first one is the method type that defines what HTTP method an endpoint is going to get. And the second type is what will be the request coming in, so the object that represents that request. And then we'll have a result type, which is actually what our actual service will return as an answer to this endpoint. And then we have our HTTP response type, which is what will be returned as the JSON object, which is supposed to be converted. So here we can see that our onMarshaller takes in the HTTP request type, and it basically converts from JSON to the object. And the same way from our response, the marshaller takes in the response type, so it does the conversion to the JSON object. But the better parts are coming now. So our request processor and response processor was where we actually benefited from type classes the most, because most of the functionality that we just previously talked is now embedded into these processors, where again we have 2 different types that it takes in. One is the method type for HTTP, and then the other one is the request type itself. And then so every single now route that extends from this will need to implement its own version of how the process will be called, and then the rest is basically will be much simpler at a specific root level. So I'll dive into the request processor, which is responsible. Better?
Better? Okay.
Yeah. All right. Great. Yeah, I can even. No, I can even see much better now. I'm like. Okay, so this is our request processor. So how we start by defining our type class. First of all, we go by defining a trait. So this trait now takes in two types, which is again the method, the HTTP method, which if I can, so I have a class here that defines all of the HTTP methods that I'm defining so that, my set is limited. And here I say it needs to be a subtype of, my HTTP method, and then it takes in the request type. And the beauty of this is that if in any case I try to use this, but I haven't implemented the necessary implicit definitions for a certain method, let's say, this actually happens at compile time that you get a warning. And Scala even allows you to customize this compile time error message with the implicit not found so that you know what you are actually missing out. Here, the ones familiar with Akka will notice it, but the directive is basically just a small block that is used to create a routing structure in Akka. So the actual implementation. Here, now I have my request processor, and depending on what endpoints, but let's assume that for this single endpoint, we will be defining two different methods, one being post and one being put. And here, I have my different input requests coming in for both of these actions. And at the end, so this is using my post request, this is using the put one. And we're basically embedding all the information that this endpoint needs to process everything. So here I have what this endpoint is going to do, so what kind of action it's waiting from HTTP, what kind of request it's going to take in, and our process basically. And these are all, again, Akka imports as well. So the post being that it's going to be a post request, and here the entity as my post request basically converts the JSON into the object. And here we're using Circe, so the marshallers are taken care of in an, again, magically implicit way. We use annotations so that the implicits are automatically defined by Circe, the JSON library, so that you don't actually need to go ahead and define the JSON. And then again, the same way, not to go over it again, but if we need to define any additional methods, it's just adding what method I want here on top of the other. And when it comes to actually defining my root, it becomes much, much simpler. So here, so compared to the original one, which was a lot thicker, here, when I define my API root and extend the generic root, I just need to specify here what are the types that I need to feed into the type class so that the processing could occur accordingly behind the scene. So here I have my, I say that unmarshaller and marshallers, which are defined implicitly. And what I only need to do is basically get the request that comes in and converted by the type class, and then I just pass it on to my service and do whatever it wants to do. So this was kind of the story, the way in. And if we go to the generic root back again, we have our second type class, which is my response, the response processor. And here again, the same structure applies. We have our trait, we can have our custom warning, and here we define, let's say, for one action here, which is one kind of processing of our endpoint. And what we basically have here is that we have our result, which is what comes out of our service, and we determine the status code. And again, we have the implicit marshaller here that's defined automatically. And then for any other process that I want to run through my service, I can keep adding onto this processor, and for any other output that I want to generate from any of the requests, it will be picked up from here and processed. Going back to, so putting it all kind of together. So now if we wanted to compare it kind of side by side, so this was, so this is what I started for a single kind of route. And basically I extracted the post bit, which is the method, and then the entity part that does the marshalling and unmarshalling, and then the full basically processing the rest of this inner structure goes into my response type class, which is handled easily with passing different types and defining implicits for each type of request and response. I think I'm all, so this was briefly the whole example. Sorry if I rushed through it. I don't know what I'm doing with the time. So this was my brief experience, and there was a point where we were struggling with some parts of the code base because it was becoming a bit cumbersome to add new endpoints. And now that we kind of extracted all these common patterns, and it took us some learning to actually make use of these kind of ideas. But once you know that there's a tool that does something, it's always good to chase it so that you make use of it in our actual example here.